how to use aspect-oriented programming to avoid code repetition for logging, exception handling, auditing, and so on. Welcome, Java Challenger. I'm Rafael Danaro, a Java champion, and I'm focused on helping you get the job you want while being well paid for that. And without further ado, let's explore the fundamentals of AOP and see coding examples. Okay, so let's explore the fundamentals of aspect-oriented programming, and let's start talking about the introduction about AOP. So with AOP, we can use the proxy concept. What does that mean? It means that we're going to use a proxy object to intercept method invocations so that we can, for example, use logging or do custom exception handling or handle transactions, whatever we need to do while intercepting our methods. So with the method interception, we can do something before the method execution, after, or around those method calls. And by using the proxy strategy, this means that we don't need to recompile the whole code because, for example, if you're using Spring AOP, what will happen is that Spring AOP will use the invocation handler interface, which is a proxy mechanism to apply the aspect logic within the method we want. And there's also performance considerations, because when we use the proxy approach, what will happen is that this aspect logic will be applied during runtime, because basically Spring will use an invocation handler and it will intercept each method invocation to do that. In most of the business applications, this won't be a problem, but if your service needs really high performance, this might be a considerable issue. And as I said before, aspect-oriented programming is also an interceptor, which means that it will separate concerns. And when we use AOP, it doesn't even look like we are intercepting our methods, because the configuration in most cases are not made in the methods we want to execute aspect code logic. So this makes the code cleaner. And since aspects, we define a rule to perform our aspect logic, we can maintain the code as it is, which is another benefit of using aspect. It also enhances modularity, because by doing that, we separate concerns and we isolate the logging logic or auditing logic or exception handling logic. So we have all of those components separated from our main code, which dramatically reduces code repetition, and it also gives us a lot more power to change logging, to change exception handling more easily, because then we don't need to change hundreds or thousands of classes if we need something different for logging or exception handling and so on. And since aspect-oriented programming doesn't require us to do anything in our business logic, this gives us a lot of flexibility to change, like I said before, our logging, logic, or whatever we want to do while using aspect-oriented programming. And what are the key concepts of AOP? So the most important key concept is that it encapsulates cross-cutting concerns such as logging, exception handling, security authentication, transactions. So we can do many useful things for our business applications using aspect-oriented programming. And it also modularizes concerns across multiple classes, which means that all of this logic is completely separate from our business logic. That gives us a lot of flexibility to do whatever we want with those concerns of our applications. And the target object basically means the object you target to execute your aspect logic. So, for example, we can target Java packages, Java classes, or Java methods. So we have a lot of flexibility to perform our aspect logic in our code. And with weaving, so Basically, there are some strategies to include the aspect logic in our code. So during compile time, this means that the framework, the AOP framework, will include the aspect code during compile time. So it's a bit more intrusive because every time you compile your code, the aspect code will be there in your method. During load time, this means that every time the Java class is loaded in the JVM, the aspect logic will be included there. And during runtime is with the proxy classes, for example, with the invocation handler interface from the Reflections API. For example, Spring AOP uses that. So basically, if you need more performance during runtime, you can use the compile time strategy. Even though it will be more intrusive, it will include code within your methods during compile time, it will be faster during runtime. So if you don't care too much about being a bit slower during compile time, you can use this strategy. Our load time, which means when the classes are loaded in the JVM. In other words, every time the class is firstly used, then the JVM will load this class. And the point cut basically specifies in what package we want the aspect-oriented programming to intercept our business requirements logic. So for example, we could intercept only packages of service, or we could intercept only packages from repository. So it depends on what is your project structure, and it depends where exactly you want to implement aspect programming in your application. And with joint point, we also have access to the method execution or to parameters or even exception handling. So this is very useful when we want, for example, to measure how much time a method is taking to be executed. So we can use a joint point to tell our aspect to continue the method execution, and then we can measure how much time this method took to be executed. I'm going to show you in a code example, but just to give you a brief introduction from AOP so that when you see the code, it's clearer those concepts. There's also the advice, which means that we can execute the logic before, after, or around our methods. And those advice are executed at a join point, which we just saw here. So now let's go to the fun part. Let's see the code. So the first step to use AOP with Spring Boot is to use the right dependency version. And in this case, I opted to use the Spring Boot starter parent dependency because then it will handle all the versions for me, which is a lot better because then we don't need to worry about having the specific compatible version here. So we simply need to add this dependency here, Spring Boot starter AOP, and then this parent POM file will take care of the versions we need. And if you need something very specific, then go for a specific version, but in most cases it's not necessary. I would just let Spring handle the versions for us. That's much easier. And let's start exploring aspect-oriented programming. So let's first explore on how to measure a method execution time. So this is the aspect class, and this is the point cut expression. And here it basically says that every class that is within this package, we will execute this logic to calculate the execution time. So you can see here that we have this package con.javachallengers AOP service, and we have this my service class. So this means that all methods from this class, we're gonna have the method execution time measured. And here we have the special object called joint point. So this object enables us to proceed with a method execution, for example. And then in this aspect, we first get the start time, and then we tell the joint point to proceed with the method execution. And then here we get the time that it took to execute the aspect method located here. And finally, we can log the execution time. So with the joint time, we can also get the method signature, which is useful because then we know exactly what was the method that from this execution time, right? So this is the method we want to test. And here we are just simulating a 1 second method execution, just to show you that the aspect will calculate 1 second and some milliseconds. So let's see here how that works. So we're going to execute only the perform task method. Let's comment out those methods for now. Let's run this. Yeah, and as you can see here, we are invoking this perform task method, which is here in my service. And then we wait 1 second, and we have 1 second and 6 milliseconds to execute this method. And this is very useful because instead of including this code in every single method of our application, we can simply create one aspect, and we can do that in every method of our application, which is handy. We make our code much cleaner with aspect. So as you could see, it works perfectly. And this is the first use case I would like to show you. Let's go to the next one, which is related to exception handling. So we have a very simple method here simulating the use case. It is this method, perform task with exception. And in this method, we are simply throwing a runtime exception. And here we have the aspect to handle our exception. And here we are getting a logger class, which is better than logging with system.out.println. It's a good practice to use a logger object because that gives us control to log in different levels. So we can log at error level or warn level or info or debug level. So this gives us more flexibility to monitor our application. Otherwise, we can create log pollution. We can create lots of meaningless logs, which makes our log reading more difficult. So again, this is the advice. So basically, this aspect will be executed every time an exception is thrown. And this is the point cut. So in this case here, every class from service will be affected. So in every class from service, we're gonna have this exception handling. And here we again have the joint point and the throwable. So the throwable is basically the highest hierarchy for the exception classes, which means, so this basically means that we're gonna get every exception that is thrown in our methods. So in this joint point, we get the signature of the method and we get the class name. So you can see that the joint point is very useful. You can get a lot of information of the code that we have, our business logic. And here we log the error, method name. Here we log the exception message and the cause if we have the cause. So it's very simple. And again, the benefit is that instead of having this logic in every method of our application, we can have that centralized in one place. And then we can change as we want in the way that is more useful for us. So let's see now how that works. Let's execute this main method. Okay, we can see a log here. So notice here that we can see the log. So we can see the aspect class, and here we can see the log. Exception in my service, perform task with exception, and here we can see the message, and the cause in this case is no. So only with those two examples, you can already see the power of using AOP. So you can dramatically decrease code repetition with AOP. It's a very powerful technique and it's available for us to use. So now let's see another example to check the return data. So this is the method we're gonna test now. And in this method, we are simply returning a list of string. And let's uncomment this aspect. And on this aspect, again, we have this point cut expression, and which means that this aspect will be executed in every class within this service package. And here we get the class name, and we show the method signature as well. And on this one, we have this advice after returning. The point cut is the same. And here we're gonna have access to the return of this method. And we simply log the result here. So let's see how that works when executing this method. So as we can see, firstly, we see this log. So let's go here. Because the advice here is before, we're gonna show this log before executing the method. And here we have access to the class name and the method signature. And then after returning, we get access to the returns data. And this might be useful for logging or for debugging. So now you can see a little bit more of the power of AOP. You can do so many things and you can reduce so much complexity in your code by using that. And here you can see the annotation. And in Java, to create an annotation, we use this keyword, we use @interface. And here we basically say that this annotation can be used only in methods and it's available during runtime. And here in the value, we're going to specify what action the user is doing within that method. So if we check here, this is the annotation, audit action, and basically in every method we have this annotation, audit action. We're going to execute this aspect logic. And in this case, it's just an example, and we're going to show the username. And like I said, and here in that case, I'm hard coding the username, but typically it's the user from the security context. And here we log the audit information. So here, for example, we log the username, and here we capture the annotation and we get the value from that annotation. And finally, we print the method signature. We could also record this action in a database, and this is commonly used within real applications, but it's up to you. It's up to your application needs. And let's see the audit logic. So notice here that we only have the audit action annotation in this method, update with user auditing. And let's see how that works. Let's invoke this method to see the aspect logic being executed. So let's go to the application. Let's uncomment this method. And now let's run this method. So we have all the other aspects, but let's focus on the important one. So this is the aspect from auditing. And here we basically show that the user test performed an update. This update information is coming from here. And here we also show the method's name. And here, as we saw before, it's doing the logging before entering the method, and then executes the method, which is this message. And then we do the aspect with the returned value. In this case, since it's a void, we just log no. And here we also show the total execution time of this method. which is only 2 milliseconds. But again, let's focus on this part for this method because that's the focus of this aspect. So basically, in any method we have this annotation, we're going to have the auditing. So for example, if we add this annotation here and we change the action, now let's also invoke return data. And as you can see here, it prints the user and the action. And then we do the same thing with the update with user auditing method. So to recap, AOP is very useful to intercept methods while having very focused aspect logic without the need of having code repetition for logging, exception handling, transaction, or auditing, or security authentication. So there are many use cases where AOP is very useful and it can dramatically decrease complexity in your code because then you can have all this logic that would be repeated throughout the whole application in just one place, which means that you have a lot more flexibility to change the logging the way you want or to do anything else you need using AOP. And I also ask you a favor to give a like and subscribe to this video, and to help you get the job you want as a Java developer while being well paid for that, I also have a free book called The Challenger Developer Guide, and I'll leave the link here on the description of this video. And I highly recommend you to get this book. It's totally free, and I wrote this book specifically to help you overcome your biggest career challenges so that you get the best positions in the market and you don't get stressed out working with low quality code or obsolete technologies. That's pretty much it, Challenger. I hope you enjoyed the video, and I'll see you the next time.